Today I'm going to talk through a linear search algorithm. Data on a computer is stored in lists, and when you want to find some data with a linear search algorithm, the linear search will look through an unordered list until it finds what it's looking for. And the key there is that the list is unordered. And it finds what it's looking for by comparing what we call a search item with data. Now, the computer can't see data, but what it can do is it can check to see if two items are the same. So if I asked you on this table of data here to find the name Celine, you might do this in different ways. Some of you might look through the data, just kind of scan around in a haphazard, hoping that you'll see, there we go, we've spotted Celine. What a computer will do is it can't just scan around. It will have a particular order in which it's going to do it. So in a linear search, what it will do is it will always start at the beginning, and it will check each item in turn to see, so in this case, does that item of data match Celine? And it will work its way through in order. So if we wanted to find the name, I don't know, Dale, so we would start here, 1, 2, check, check, no, check, check, no, and keep going until we find the search, the item that we're searching for. Let's take a different example. So we've got some data here that's stored in a list, and say for example we're searching for the number 98. Where does it start with a linear search? Is it going to start here? Is it going to start here? Or is it going to start here? Okay, so the first item that it looks at, and it will check, is that equal to 98? Yes or no? And in this case it's not, so it looks at the next item of data. That doesn't equal 98. And we keep going and keep going and keep going until we find the item of data that we're looking for. And in this case we looked at 1, 2, 3, 4, 5, 6, 7 items of data until we got to the one that we wanted. Now this particular list that we're looking at has 8 items of data. So how many items of data will it have to look at? Well, best case scenario is that it only needs to look at one. So for example, if I'm looking for the number 3 and it's not there, 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 it's the last item. So that's actually the worst case scenario. So we looked at 1, 2, 3, 4, 5, 6, 7, 8. So with 8 items of data, and if it's at the end, number 3, worst case scenario is we have to look at all 8. Best case scenario, so in this case if we're looking for the number 5, it's the first item that we look at. So the fewest number of searches in a list would be 1. Okay, we'd only have to look at one other item of data. Okay, just get rid of those. So this is a different way to look at the linear search algorithm, and this is a flowchart, which is what we've covered before. So at the start, where you begin and then input searched value, that basically means what are you looking for? And then for each value in the list or each item in the list, if that value is equal to what we're looking for, then that would be true and we would display found it, and then you would end. If it's not what we're looking for, if that is false, then the next thing we do is we read the next value. We go back up here, okay, and for the next value we would look to see if it's equal to what we're looking for. and it would continue with this until it either finds it, or if it gets to the end of the list and it still hasn't found what it is you're looking for, then it would display not found. Now, there are some problems with the linear search. So as we've explained there, every item of data must be checked, even if what you're looking for isn't there. So if you had 1 million items in a list, the computer would have to look through all of them, which, as you can imagine, can take a long time depending on the size of the list. Linear search obviously works okay with smaller sets of data, so it's not completely useless, but there are more efficient searches that we will look at which don't have the same problems. The advantage, though, of the linear search is that you don't have to sort the list in order. So the list can be a mixed up list, a muddled list. It doesn't have to be in order, which in some cases makes a difference and it is better. Okay, so that is your linear search.